see it?
I can see over you, but the back of your head is really well framed.
Okay.
If you move like a foot that way.
Is that better?
That's really good. Yes. Straight shot.
Should have said something.
It's hard to get both the screen and the person at the same time.
I know. It's really cute.
We make it really like 5 months after
This is actually Crandall Chapter. Yeah. They need more
All right, so it's my distinct pleasure to welcome you and introduce our speaker, Elika Bergelson. She is the Crandall. I really love that you put it there too, because I couldn't figure out how to pronounce. And then I think I did, and then I forgot to pick it up. So, who is the Crandall Family Assistant Professor in the Department of Psychology and Neuroscience, and Linguistics, I would have missed that, at Duke University. Elika earned her PhD from the University of Pennsylvania, and then worked with Dick Aslin at University of Rochester before becoming an assistant professor at Duke University. I'm really excited for this talk. I assigned her articles, in both in my lab and in my advanced undergraduate classes. She's doing some of the coolest work on early language acquisition. What's really impressive about her research is the combination of methods that she uses, both in-lab techniques with eye tracking, but also uses in-home measures as well, where she records everything that's happening in the home environment. And if any of you have ever collected data with kids and tried to capture the input, it is a huge amount of data. So I applaud her for her brave efforts.
In the tush, mostly.
Yeah. For these, it's an amazing approach to really try to capture what the nature of the input is within the home. And what's really cool, I don't know if she'll talk about, is the way she's able to link infants' experiences with home environments with their assessments in a lab in their looking time comprehension. She has a number of distinctions worth mentioning. She is the recipient of a 2019 NSF Early Career Award, which is a really big deal. And as if that wasn't enough, also an NIH grant in the same year. All looking at early language development, and she already had an NIH award, and as well as a National Endowment for the Humanities, so really impressive. And in line with this, she has several distinctions, and many more to come, I'm sure. 2014 Best Dissertation Award from the Infancy Society, 2015 Rising Star for the Association for Psychological Science, and my favorite, Forbes Media, 30 under 30. So
I'm over 30 now, so it's all downhill.
So, yeah, I think I would be delighted if I made it to a really old age and learned this.
I'd rather be 60 over 60. That would really be an accomplishment.
Right? So, without further ado, please join me in welcoming Elika Bergelson.
Right. Thanks for coming in on this President's Day. I'm glad I could bring some warm weather up from the south for you. You're welcome. They would call this a totally freezing day where I'm from, though, so I'm glad for an opportunity to take my winter coat out of the closet. All right, so I'm going to be blasting through a lot of data. Feel free to stop me and ask questions at any point in time, and if I don't want to answer them, I won't. But I'd rather you ask. All right, since my understanding is that this is a bit of a mixed crowd, I want to start by explaining why I think it's worthwhile to study infant learning, and making crystal clear the two main reasons that I study this area. And the first is that from a basic science perspective, early word learning is a really hard problem. So you start out with noisy input. Noisy in the sense of ambiguous input, noisy for a given kid, noisy across and within modalities in terms of speech stream segregation and object recognition, and noisy in how vastly the input varies from one person to the next. And you add to that an immature learner. So babies are bad at a lot of things. They struggle to locomote, they can't read social cues very well, they can't feed themselves, they drool a lot, and frankly, they sleep for most of the day. And yet somehow, when you combine these two elements that might not be optimal for a learning system that you create, you end up quite quickly and rapidly with a language learning machine. So babies land on this community-wide convergence of the language of their community within just a few years' time, despite this immature state and despite the noise in their input. And not only that, but the source for languages, which vary quite a bit, and they do a better job, generally speaking, than grown-ups who try that same kind of learning exercise many years later. So I think figuring that out from a purely basic science perspective is going to give us great insight into the human mind. The second main reason that I study infant word learning is that from a health perspective, early language development really matters. So there are millions of kids in the US and elsewhere with a variety of language-related clinical diagnoses, ranging from ASD to SLI. And the problem is that these deficits are generally lumped together and not identified until kids are able to start talking, even though they start understanding and doing things with their speech knowledge far before that. So I think that understanding early language development is going to give us a better chance to identify and treat language delays, which we know have knock-on effects for things like reading delays and other kinds of skills later in development. More broadly, we also know from some work that my lab has done, lots of work others have done, that there are differences, for instance, as a function of socioeconomic status. There are differences in the ways that one might provide optimal or helpful or supportive learning experiences for children coming from different backgrounds. And the more that we can understand about parent-child interactions that might be supportive, the better job we can do in helping all families thrive. So I study infant word learning because the science is deep and surprising, and because there are serious and clear implications for human health. So that's why. What about how? So there's sort of two main tacks that one might take, and Marianella alluded to this in my kind introduction. So you can either bring the baby into the lab and poke and prod them with your experimental methods and try to figure out what's in their head. I also talk really fast, so if somebody needs to flag me down at some point, tell me to slow down. Feel free to do so. I usually get an audience member with like a secret hand signal, but I forgot to do that. Okay, so you can study the learner directly, or you can study sort of the learning substrate. What are they learning from to help figure out what gives rise to their knowledge. In my work, I do both of these things, and I'll be telling you about both of them today. So I'm going to start by telling you about some findings purely from studying the learner, some stuff from studying the input, and some stuff from linking the two. I want to say just a few brief words about previous work on early language learning, and early word learning in particular. Mostly to say, this was sort of the state of the field when I first got involved. The received wisdom was that first you figure out all your sounds. Once you have your sounds squared away, you start linking sound to meaning, then you might figure out grammar, pragmatics, sort of up the levels of linguistic representation. And so this led famous people like Patricia Kuhl to say at 6 months of age, infants can't understand words. And I don't put that up there because it will turn out that she was wrong. I should be so lucky that anybody found it notable that I was wrong about something. I'm wrong about lots of things. But I put it up there just to say this really was sort of the viewpoint in the literature when we first started doing this kind of work. And the other thing that I want to just preface with is, not to sound like a Maybelline commercial, but age is just a number. So I think that as our methods get better and as our techniques get better, we're going to find that babies do X younger than we thought. That just means that we're making scientific progress. That doesn't actually necessarily mean that we're uncovering new things. So we should find the prerequisites of skills earlier than we thought. The reason I think looking at young babies is informative is because if you have a theory that says you're not going to get skill A until you have skill B, and I show you skill B in a creature that doesn't have skill A, that must mean your theory is wrong. And so I think it's interesting to look at young infants because it makes us reevaluate our theoretical models. Okay. So I'll start with some key data points we find from studying the learner. This stuff I'll go through a little bit more quickly because this is all papers that are out and I want to spend more time on stuff that's still not quite out yet or more recently out. I'm going to show you some data that says that from about 6 months, babies are starting to understand nouns for common foods and body parts. From about 10 months, they're starting to understand more abstract non-nouns, we call them. But that their early representations are still immature. They don't have exactly the right sense of how the word is supposed to sound or exactly what it's supposed to mean. This is still developing on cascading timelines. And then the other thing that we've been thinking a lot about lately is that there's this big, I call it dramatic, I guess that depends on who you are, what you define as drama, this big improvement at around 14 months that we want to think more about. Okay. So in most of the eye tracking studies that I'll be telling you about today, the setup looks something like this. You have a baby sitting in his or her parent's lap. This is a eye tracker that tracks where the baby is looking. And the little tripod you can see in the back is a camera that's at the same time just capturing the scene in case later we wonder, why is there no data? Oh, it's because the baby was screaming the whole time. And so the way this works is, in some of our studies, parents are wearing headphones, and so they'll hear a sentence that then they'll say aloud to their child. And then we measure, does the baby look at, in this case, the apple or the mouth, across trials, across kids, across all the counterbalancing we'd want to build in. And so to just give you a sense of what kind of data this generates, this is going to be the eye movements from one 7-month-old from one trial. There's this little counter in the corner that the child didn't see, and this green dot moving around is the baby's eye.
Can you find the hand?
Okay, that's the nature of the data. So there's a million ways that one might analyze something like that, and I'm happy to get into the details if anybody really cares. Usually people don't. But basically you want to arrive at an estimate of, did they look more at the right thing after it was named? And you might do that relative to where they looked before, or relative to another trial where the other picture was the target. But you derive across infants, across items, did they look more at the right thing? And that's your proxy for word comprehension. Okay. So in this first study, we showed babies generally, there are a couple of trial types, but on most trials, babies saw a display like one of these, without the words there. And so these are all foods and body parts. We picked those two categories because they're pretty consistent across kids' experiences. So most hands look kind of like that hand, most bananas look kind of like that banana. And what we found in showing kids trials like this, so this is every little lollipop, if you will, is a baby, age on the x-axis, and how much more they looked at the right picture on the y-axis. And what we found is that, in a surprise to us as much as to anyone else, even at the very earliest age groups, they were already looking just a little bit more at the right picture across trials. So that's the first notable thing. So most of the babies across most of the items were looking at the right picture just a little bit. And then performance is really quite stable until around 14 months. You can see that line's pretty flat, and then it really gets a lot stronger. So I can collapse this into a bar chart to make it a little bit easier to see. So basically you get this modest but consistent level of performance between 6 and 13 months or so, and then this big boost after they turn 1. So that was our first bit of evidence that babies are starting to understand some common nouns from their home experiences like foods and body parts. So then we thought, okay, well, let's try to push this further and look at some more abstract words like non-nouns. And to just show you a different kind of representation, I'm just showing you the item pair level data, though I have the subject level too. What babies would see in the study are little video vignettes. So it would be somebody kissing a teddy bear and somebody dancing. I probably have the videos somewhere, which are funnier than I am. But what you can see here is a different pattern. So now the 6 to 9 month olds, half of those bars are a little bit up, half of them are a little bit down. They're really not performing well. At 10 to 13 months, they're starting to show, most of those bars are positive. They do, at above chance rates, understand that set of words. They're especially good at kiss dance, and you can make whatever conclusions from that you like. And then by 14 to 16 months, they're really every single pair is showing positive performance across the board. And so what's interesting about these more abstract words is that while, as I said, most bananas look similar, most of the different instances of uh-oh can really look quite different depending on what kind of incident you are experiencing. So it requires a bit of abstraction beyond your experience to recognize a novel instance of uh-oh you've never seen before. So this suggests there's a little bit something a little bit fancier going on in the kind of generalizations babies are making in these studies. Okay, so then the third studying the learner data point is that word form representations and meanings are maturing on cascading timelines. So in the studies I've talked about so far, I showed you mom is saying the word, baby sitting in her lap, and there's an experimenter behind the monitor. And so to look at infants' phonetic representations for how words sound, we messed with this structure a little bit. So in one condition, we'd have moms on purpose mispronouncing words. So they'd say, look at the opal instead of look at the apple. Babies don't know about semi-precious gems, so you don't have to worry about that. And we would see, did they still look at the right picture, right? Because it still is, apple is still a better match than mouse, even to the word opal, right? And then in another condition, we had the experimenter saying the sentence instead of the mom. And just to make the perhaps obvious point pretty clear, the difference between a sound, speech sound occurs in tens of milliseconds, but it can change the meaning of a word. A difference between a voice is super different. So Mike, say the word apple.
Apple.
Apple. When I and he say that word, it sounds very different across a number of measures that you could measure. But phonemes last a very short amount of time, but they're really critical for meaning. So if somebody tells you they like your smell instead of your smile, that's super creepy, right? And that information was transmitted in like a very tiny amount of time. So you have to track the small changes, even though the cross-person changes are much bigger. Okay, so what do we find when we test babies on these things? So I already showed you that with the mom pronouncing the words in just the typical way, babies at all these ages are doing just fine. For the youngest babies, they seem to do just fine when mom is mispronouncing the word or when a new talker is talking. They look still just a little bit at the right one, whether you said opal, whether the person talking was a stranger to you. So that's too permissive on the pronunciation side, but the right thing to do for the talkers. Then at 8 to 10 months, they go through a phase where they aren't good at either manipulation. We call this the confused state. And there are some reasons we think that might be what's going on. Or the confusion makes sense at that stage of lexical reorganization. And then by the time they're getting closer to their 1-year birthday and beyond, now they're doing the right thing. So if the word is mispronounced, they look less at the image than it was pronounced correctly. And if there's a new talker, they don't have any decrement there. So that's the adult-like pattern. Okay, so from 6 to 14 months, we see this maturation across word forms. At a few points in the talk, including right now, I'm going to flag things that I'm not planning to talk about, but that if you want to ask me about, I have secret slides prepared for. So, one of them is about updates about 8-month-old confusion, and one of them is about how these kinds of mispronunciation effects work for things like verbs, which are more likely to change their vowels as you conjugate them, for instance. Okay, so that was our manipulation of the word form. We also looked at manipulating the word meaning. So on some trials in this study, babies would see, for instance, a foot or a cup of juice. I know that to grown-ups that doesn't look like a cup of juice. It is a sippy cup of apple juice. We did one time have a kid say beer. That was really embarrassing for everyone involved, mostly the mom. But it is a sippy cup of juice. Okay, so on some trials they would see this and they'd hear foot or juice. On some trials they'd see this display and they'd hear look at the sock or look at the milk. And what the point obviously is there is no sock up on the screen, but there is something that is more related to a sock, and there's something that's more related to milk, and the question is, what do infants do in this case? Do they look at the related thing or not? And what we find there, now this is 12 to 18-month-olds, again, every dot is one baby. What I'm showing you is how well they did looking at the right picture when the word and picture matched versus when they heard the related thing. And what we find is in this sort of first half of this age range, they're too permissive. They look just as much whether you said sock or foot, even though there is no sock there. At around 16 months, closer to a year and a half, they start to do the right thing, the more adult-like thing, which is they look at it less when you say sock instead of foot. Anecdotally, you occasionally get kids that will say things like, when you say, do you see the sock? They'll say, nope. But they don't do that often enough that you can really measure that. But it seems like they have closer to a year and a half, which is also when they can start to do things like mutual exclusivity, learn words from context. They are more sensitive to the meaning of a word. But this is many months after they've started to do this with mispronunciations in the phonetic space. So for over 12 to 20 months, and certainly thereafter, word meanings are continuing to mature, but they seem to be doing this a little later than word form representations for the phonetics. Okay. So then the fourth background point, this is a busy slide, so I'll walk you through it, is that this is what I was saying is the high drama, the big improvement that we see. So this is 6 different data sets. Some of them I've just talked to you about, some of them I haven't. In every case, one little symbol is a baby, ages on the x-axis, and how much they looked more at the right pictures on the y-axis. And what we see in some of these, the stimuli are videos, and some of them they're images, in some of them they're nouns, and some of them they're not nouns. In some of them they're longitudinal, and some of them they're cross-sectional. But what we seem to see over and over across this set of studies, across now hundreds of babies, is there's this big non-linear improvement right after the first birthday. They get a lot better at understanding words in this word comprehension task. And intriguingly, if you actually instead ask parents how many words they think their kid knows, that improvement looks linear. So if you just get a parent report about how many words does your kid know on the survey, it looks like a straight line with nothing special happening at 12 to 14 months. But when we get this really fine-grained, real-time, online processing of words, we see that there's this big boost. And that's one of the mysteries that we've been working to solve, in part by collecting the home data. But to just give you a sense of what the same kid looks like doing an eye tracking study every other month for a year, I'm going to show you a little bit. Oh, look at the diaper. Can you find the ball? Where's the tooth? Where's the tree?
This is making me feel
Where's
better.
the chicken? You see the eye? Look at the bread. Can you find a banana? Alright, so obviously this is pretty cherry picked, but this is something that generally is what we see, right? So the littlest ones, they're kind of lumps, they sit there, they do the thing. Then they realize they don't have to sit there, and they don't. But then at around 14 months, it's like there's a switch flipping. They're like, oh, I get this, you're talking about the stuff up there. And by 18 months, the kid was naming the pictures before mom had even labeled them, right? So that's a sense of this dramatic improvement. Okay, so to recap those four data points again, from 6 months on, we find that babies are starting to understand these common nouns. A few months later, these more abstract things that are going to look different instance to instance, like uh-oh and all gone. But we still see maturation. It looks like first of the phonetic representation and then of the semantic representation. And we see this big boost at around 14 months. So everything that I've just told you is the outcome of some learning process. So you're a baby, you're living your life. You come into the lab, you do this study. It takes less than 10 minutes. And then we draw big conclusions about what's in your head. But I started to realize, trying to put these pieces together, that we need to actually get a sense of what the input to babies is like that gives rise to this behavior that we're able to observe in the lab. And so that's sort of what the next adventure has been. It's easy to put a box and arrows on a slide and claim that you have a theory of some kind. So I want to say a little bit more about what I am hoping to do by looking at how the input gives rise to the outcome. So the first point to make is that we learn from particular interactions. You don't ever get exposed to bird in general or the word shoe in general, right? You hear it from people in the kinds of day-to-day things that you're seeing. And from those kinds of particular experiences, you have to generalize, right? You have to derive or induce or infer these categories in a way that lets you make just the right conclusions and rules out the wrong conclusions. And so figuring out what that process looks like, I think, requires looking at the input closely to see how it gives rise to the outcome. And it also might be the case that the way that you first break into a system, your earliest steps, might not be the same as what you do once you have a few words, for instance, in your lexicon, and then you need to build on them further. And so trying to figure out how that works is part of the goal. So I'm going to tell you a little bit about how we've been doing that by looking at how we study the input. Okay, we're nearly at the audience participation portion, so get excited. I'm going to show you a couple more videos. So what you're seeing here is this little guy is wearing a hat with two little cameras on it. One of them's pointed slightly up, one of them's pointed slightly down, and then there's also a camcorder in the corner recording the whole scene. So if life were like this, it would be easy to learn words like train.
You think it'll make it down? Here comes the train. Here it comes. You reach it?
Okay, mom and baby are looking in one direction. There is this looming toy coming towards them, shining lights. Mom is labeling it. It's singing a song about being a train. So if life were like that, it would be trivial. And so one question is life like that, or is life messier? So we are now at the audience participation moment. I'm going to play you another video, same kid. I'm going to play it without the sound, and I want you to guess what mom's talking about, and you can just call it out when you have a guess. heard rattle. Other guesses?
Caterpillar?
Caterpillar, reasonable guess. Any other guesses?
I'm gonna go verb, just because I feel like that
Okay.
kid doesn't get their voice as much.
Okay, all right, what verb would you put on that?
Oh, look at it, shaking, shaking.
Great, shaking, shaker, rattle, toy, caterpillar, all that seems reasonable. The answer is cornbread. So I'm gonna play it again for you with the sound on.
You might like cornbread.
All right,
Here we go.
Mom is talking over her shoulder to her husband, oh, he might like cornbread, as she shakes this rattle in the kid's face, right? So if life is like this, it's actually gonna be quite hard to learn anything, and maybe he's gonna have a whole protracted phase where he's confused about whether bugs are edible. But we don't really have any reason to think that actually happens. And so part of our goal is to figure out what is life really like. And so this was part of an effort which has generated what we call the seedlings corpus, which stands for Study of Environmental Effects on Developing Linguistic Skills, which is much cuter as a backronym than as a thing to have to say. And in this project, we collected about 9,000 hours of naturalistic data from 44 babies. So here's how it worked. We had babies start the study when they're about 6 months. That's when they're first starting to understand words. They finished at 18 months when they're generally just starting to produce words. And every month, we would get day-long audio recordings. Babies would wear this little vest, and we put a little recorder inside of it called Alina, and they turn it on first thing in the morning and turn it off at the end of the day. And it collected modally and up to 16 hours from the home environment. And then similarly, those videos I was just showing you are from the videos of the corpus. Those we do once a month on a different day. We put little cameras on their heads at their house and record for an hour a month for a year. And then critically, for our purposes, we bring those same babies back into the lab to do our eye tracking studies so we can start to build links between the home environment and the precise in-lab word comprehension that we're interested in. A caveat that I like to give is that this is a non-representative sample. It's a sample of the kinds of families who you can go to their house or they can come in between 9 to 5 Monday to Friday. That's a bummer, but that's what you have to work with. All right. I think this is my last video, I'm sorry to tell you, but here is a montage for one kid, a year in the life of the kind of thing we've done.
Yeah, good job. Oh, goodness. So close. Yay, you got it. Beep, beep. Good job.
Rochester exit for you.
You can stand up? Oh, my goodness. Yeah. Ready? Here it comes. Oh. Make her go down the slide. Yeah, that's... Oh, no, that's a cow. What's a cow? Let me see, muscle. Is the elephant? Yeah. Where's the dirt? Shoot! Yay!
All right, so that's just to give you a sense of the kind of data that we're collecting over there. Most of it's not that exciting for the whole hour, right? We cherry-pick this. So to give you a little bit more of information about the sample, so we got these monthly hour-long video recordings, monthly day-long audio recordings. These babies are from upstate New York, just about an hour away. About half female, all learning English, majority English input. And like I was just saying, it's a convenience sample, so it does not reflect the demographics of the U.S. Yeah.
They weren't all firstborn?
They were not all firstborn, no. Because I don't think that's a good rule to have about the data you collect. We can talk about it. Reasonable people disagree, but for our purposes, I did not only have firstborns. Okay, so what do we do with this huge pile of data other than feel overwhelmed? We annotated some things in it. So we marked every time there was an object word, which about maps onto concrete noun, that was either directed to or said by the baby in these recordings. And for each of these, we would mark what the word was in the particular way that it was said, what type of utterance it was, which we split into a couple of theoretically motivated categories based on previous research, whether the thing being talked about was actually present and attended to, which turns out to be an important property, and who's talking. And then we converted the word, however it was said, to what you would call the basic level or the lemma of the word, because there's different kinds of things you might want to count. Okay. And so we've done this kind of annotation for all of the videos in the corpus and parts of each day. It turns out that you can start off very optimistically thinking it will not take you more than a day to listen to a day. And And then you quickly discover that it takes longer than a day to listen to and annotate a day. So anyway, we had at least 3 hours of every day annotated and used some algorithms to spotlight the parts of the day that had more talking in them, and I'm happy to answer more questions about that. Okay, so object words and the inputs. I'm just going to tell you some of the data points that are coming out of this. Infants are hearing about 700 object words. Word tokens in a day are about 50 types of words in a high volume hour. Most of their input is coming from just 1 or 2 people, usually mom and another caretaker. Most of the utterance types are declaratives or questions. I'm going to show you a figure of this in a second. And most of the time they hear a word labeled, it's present, though that varies by utterance type. So if you're hearing twinkle, twinkle, little star, there isn't usually a star there. But if you're reading a book about a train, there's usually a train there to be learned from. Okay, so this might sound like, you know, cool things Elika tells people at parties, but I think they're more than just factoids. They actually help us build theories. I want to show you a graph and then come back to that point. And the sort of next point to make from that is that the properties of the words in the input are incredibly stable over time. So this is some of those properties I just told you about, the number of tokens, the number of types, the proportion of object presence, and the different kinds of utterances they were hearing. This is just from the video data, since that's all 1 hour every month, and age from 6 to 17 months. And the main thing that you should notice is that there's a great deal of variability across kids. That's why the violins are wide. They're wider where there is more data. But also the input is incredibly stable. In some cases, there's maybe a slight uptick in the slope, which is because the kids' own productions are also in here. But generally speaking, something like the proportion of declarative statements and questions hovers right around 70% of the input from 6 to 17 months. One of those categories, I know some people in here are interested in words of isolation, is we get about 10% of the words babies are hearing in isolation from 6 to 17 months, consistent with what's been previously reported in the literature. Okay, so what's the theoretical significance of these variables? Why would we care how much of this kind of stuff babies are hearing? Well, lots of folks are interested in building the right model of how the infant aggregates over their experience. And if we don't actually know how many words and what kinds of words babies are hearing, we're not going to be able to build those models correctly, either from a computational direction or from just a modeling the data itself direction. In terms of phonetic variability, if it's useful, if you have a theory that says, well, to really learn your phonemes, you need to hear lots of talkers say words in lots of ways. It's useful to know that 70% of the time babies are just hearing one person, maybe 2, because that's going to alter the kind of data you have to learn from. The words in isolation point I just made, it's a thing that makes it easy to tell where a word begins and ends if you just hear ball. That's a lot easier than if you hear, here comes the balls rolling at you, watch out. So that's, but if that only happens 10% of the time, that's going to be useful also to build into your theories. And similarly with object presence, whether the kid knows what you're talking about or not is going to make a difference. So if you know what a shoe is and I say, I'm going to go get your shoe, I didn't just ruin your ability to learn that word because you weren't looking at a shoe when I said it. But if you're at an early, more precocious or fragile state, that might be data that you're factoring in as you build your representation. Okay, so then for the remainder of the time, I want to talk about a variety of efforts that we've had